Hi everyone, welcome to another episode of Munro Live. Jordan Rocha here. I'm with Kevin Hardy as well.
How you doing?
We'll be walking through, as you can see now, the rolling chassis on the all-new Lightning. So as we go through this, we'll be making some comparisons. If you remember back, if you saw the video, we did a similar video on the Rivian with actually my boss, Scott Hildreth, and I did that one. And so we'll be making some comparisons to sort of ground you in the differences between the two as we walk through. And so just kind of hang with us and we'll work through. One of the first things that we want to point out is the isolation differences. So what I'm talking about in terms of isolation are these rubber bushings here that are bolted to the frame. So these are the primary interface points between the ladder frame. So it's this steel frame that carries the drive modules, a lot of the high voltage modules, the suspension components, a few of the cooling elements and so forth. So the frame to the body, this is that primary interface point. There are 14 of these points from front to rear of the vehicle. So there are 6 points that are connecting the cab to the frame. And then there are another 7 points that are connecting the bed to the frame. So overall 14 points. If you remember the Rivian video, there were over 100 fasteners connecting its frame to the associated cabin bed on that end. So significantly less, as we had mentioned there. So in terms of just the ability to deck 2 or 3 major monuments like this, the number of points that you need to accommodate in terms of GD&T, locating, indexing, all of those things. This is orders of magnitude simpler. In addition to it being simpler, you also have some compliance in these bushings. So even with my bare hand, right, you can see that I can move these points around. So if there is any stack up variation in these welded assemblies as they get joined, this is going to be a little bit more forgiving as you go to deck them. Not surprising, as it's the F-Series pickup truck, and they're making hundreds and hundreds and hundreds of thousands of these per year when you can take into account their full portfolio. And many of these points are very similar, if not identical, to a conventional F-Series truck, so a conventional ICE application. So they're getting a lot of benefits in terms of just manufacturability here. The other key difference that you're going to see on this rolling chassis versus, say, a Rivian is that there is no additional subframe below it. So all of the chassis components, the control arms, the strut, the steering linkage, all of those elements are bolted directly to the frame. So those are all going to be built up on the frame versus a separate cradle that then needs to be decked from the underside. Also, on the top side, you don't see nearly as much cross-car structure, specifically in this general area, right? So this is where the frunk would typically reside, or does reside rather. And then here we're getting closer to the dash panel. They don't have as much cross-car structure here. And so, as I mentioned when I did the front end review on the Rivian, to me the Rivian seemed like it had redundant structure, specifically because we're seeing on trucks like the F-150, like the Ram, albeit I see applications on some of those other cases, there just isn't those same monuments here. And so it would lead you to believe that they don't need them. And so when we talk about Rivian and their ability to optimize, I think they have a lot of potentially redundant structures here that they can maybe get rid of or optimize quite a bit. So Kevin, when you look at the front end of this truck, what are some things that stand out to you with regard to packaging overall? Obviously there's a lot going on here. What do you see?
So yes, there's a lot of lines, a lot of brackets kind of leading off this, but one thing that's very, very apparent to me, when you look at essentially the planes here coming across the top, down through here, if the body was still on this, there's a steel kind of cross member that runs across, there's a series of concessions from a packaging perspective for the frunk. So it's very, very clear that there's a lot of priority put on the usability and size of the frunk. Personally, one of the things I love about the Lightning over the Rivian is the front access, just how much easier it is. And I'm a relatively tall guy, to get stuff in and out of the frunk on the Lightning in comparison to the Rivian, where I have to bring things up and over. And you see kind of in general, aside from this plane here, even the cooling module. So the Rivian is much more upright and forward of, they're not exactly analogous, but forward of this mount here, if this was on the Rivian itself, where Ford has laid this down nearly vertically, and then essentially has an AGS shroud for the intercoolers on the ICE vehicles, but for this particular cooling module on their BEV.
So active grille shutters is AGS.
Running back through this. But it's kind of interesting what Ford has done to get the packaging volume that they need for the frunk, but at the same time, they're, as Jordan mentioned, this is kind of constrained by the ICE cab. So the frame rails, their width, all that stuff is common with the overall cab. It helps them a lot in some areas, but it's also a significant like legacy tie-down point for them. But when you look at essentially some aspects of the cooling loop that are now separate from the module and packaged outward on separate brackets, and they're pushed outward because essentially the frunk runs all the way out towards here and then up here as well, and then there's a trap door for the 12-volt battery itself. When we first pulled the trunk out, everything I saw was kind of exactly what I expected to see. Essentially nearly common, if not identical, shock towers, significantly lower due to the essentially disassociated front axle on the ICE trucks, and a very, very low EDM on this vehicle itself. There is a pretty large and sizable casting that supports both the EDM, the inverter, and all this other stuff, all these other modules.
Yeah, you can kind of see it right here.
Yeah, right? This cross hatching is kind of indicative here on that piece that we're speaking to. I understand, the rush to get this to market, and the timing and the validation and all those constraints, but I would have liked to have seen, I think, more of a manifold approach. I know we're kind of spoiled with the Tesla's module. It has a crossguard beam that goes across the front, the octavalve, the heat pump, all that stuff. It's tightly, very, very tightly packaged. They use a lot of castings to integrate those separate lines and separate routing paths. But that's the biggest thing I understand why it's not like this on this vehicle, but maybe on a second or third generation, I would expect to see significantly more integration kind of moving forward. But, as Jordan mentioned, this is pretty much straight from the ICE playbook, and the overall height of these shock towers are significantly lower, which maybe speaks to your point is from the redundancy. The loads and the cantilever effect on these shock towers is just significantly less, on this particular vehicle based off its architecture and how high the frame section height is on this vehicle.
Yeah, and maybe to shed some more light, when Kevin was talking about some of the Tesla applications, the octovalve, the super beam, those things, that's what I would like to refer to as systems engineering or cross-functional integration, where the guy that owns this module is communicating with the guy that owns this module. They have design latitude. On the other applications, the Teslas, for example, they do a pretty good job as far as the industry is concerned in integrating modules together. But what they gain in return is, for every one of these modules that needs to be thermally managed, you've got a discrete line for inlet outlet for coolant going to this module, a discrete high voltage connection, some low voltage connections. You've got to ground it separately. There's additional fastening. There's brackets on the B side of it, right? So that speaks to the fastening. So all of those things, they have to do over and over again, right? Or anyone does if you've got separate modules, which is indicative to us that they're buying relatively off-the-shelf or supplier-driven modules versus designing some of this stuff more in-house as far as the high voltage is concerned. And so you don't just get to make a decision, well, we're going to do systems engineering. There's a lot that goes into it with regard to the financials. You need to make sure that you have confirmed volume enough such that you can amortize all of the tooling, the ED&D, so engineering, design, and development, to create those modules in-house, to validate that in-house, to do all of those things. That's not free. In fact, it's incredibly costly. And so if you are on the sort of go fast track, right, you're getting a first article in the market, which for the F-Series truck, this is a first article into the market, dipping into the BEV world. It's not surprising to me that we see this. However, I would really hope to see on some future generations or iterations that they take some of these high voltage modules, integrate them for their sake, right, and get some more systems integration level benefit from that, right? Some reduction of fasteners, better packaging. I think as far as it stands today, they have an industry-leading frunk in terms of its overall size. I think they could improve that even further if we do some more systems level engineering. But overall, looking at this thing, we talk about built Ford tough. That's kind of their motto, right? It certainly is. Looking at some of these stampings, we're seeing stampings on this frame that are upwards of 4 millimeters thick, which, if you know stamping, that's pretty substantial. And furthermore, unlike what we saw in the Rivian, a lot of the welding seams and beads, it is all very well executed. We're not seeing hardly any beads on this frame that I would say are retouched, right? They had a welding issue and had to go back over the top of it, or it's an offset bead where I don't think they're making a good connection. We're not seeing any of that, to no surprise on an F-Series truck, whereas on the Rivian, it was sort of riddled throughout. So no surprise there. I'll touch really quickly on SORB, and then we can move back a little bit further. So for those of you who don't know, SORB is Small Overlap Rigid Barrier, conducted by IIHS. They're an insurance institute. And so what they do, it's an impact or crashworthiness test where they take 25% of the overall vehicle width, and they'll run it on both driver and passenger side. They used to only do it on the driver's side. Now they run it on both. So the OEMs now have to put structure in that 25% zone to help absorb some of the energy, thus protecting the occupants that sit rearward of those monuments. So to me, these are pretty obvious SORB countermeasures. So this, like an outrigger, right? It's not actually connecting anything else. Nothing is mounted to it. Nothing is on top of it. It's just bolted into one of these perch mount outriggers. And so to me, that is one of the first structural engagements on the frame to the SORB barrier. So they're helping drive some of that load into the frame rail versus kind of blowing past it, engaging this whole suspension corner, and then moving rearward. To supplement that, on the top side, so on the body, they've got some hydroformed rails that simultaneously would be engaging with that barrier. So they've got an upper load path, we would call it a upper load beam or a shotgun, and then a lower load path, which is being supplemented by these monuments that I was just pointing out. As you get to the back of the vehicle in a more defensive manner, they've got another outrigger that's welded to the outboard side of the frame rail, this right here. So as you go through the event, there's a lot of weird kinematics that are going to happen, but this wheel at some point is probably going to load up in the, I'll call it the torque box area, which is typically rearward of this, into the hinge pillar as well, that whole section of the vehicle. And this is going to help manage some of that energy furthermore. Again, the goal is protecting the occupants. And as far as SORB packages go, this is about as simple as it gets. We've seen some extravagant executions with Volvo. Rivian's got a lot of hardware in their vehicle as countermeasures. This is pretty simple. So from a lean design perspective, pretty good. Moving rearward, so now we get to where everything is getting packaged with regard to the battery. So we've got a relatively large cavity in the middle of the frame. To me, it's pretty obviously a BEV application because there's hardly any cross members that are PIA or part and assembly to the frame. We've got one cross member right here. And to me, this is a dedicated member that's going to help manage some of the side pole impacts, right? So side pole is another crashworthiness test where they're hitting it from the side. So it's protecting both the occupants, anything cabin side, as well as the battery pack, which is going to kind of live in this area here in between the frame rails. So you're seeing that they're reinforcing that. That's what this additional plate is on the outside. They're reinforcing that member as it attaches. This would be called tube-in-tube. It goes through and it's welded. So they're reinforcing it on the outside as well as on the top of the member. So I think they're doing quite a bit, as well as in this same general zone, you're seeing that between the front frame module, which is essentially the front third of the frame, and the mid frame module, which is like the middle third, separated by this joint right here. They're reinforcing that joint further, and I would place money on that. That is probably also from a side impulse or side impact perspective. Kevin, maybe if you want to talk to what they did from a tow package perspective. thermal management?
So as we kind of come back to the back side of this, unfortunately, we're seeing a lot of EPDM lines. Similar to the Mach-E, I would imagine, I think at this point, they're probably working quickly to either do some blow molded, manifolds, at least some nylon lines, because they're significantly heavier. You have to control, their routing and their mounting a little bit more than you would with or a little bit less, excuse me, than the EPDM lines. And then just kind of, as we come back here, there's one EAC compressor here, and then there's a supplementary one here. On some of the earlier vehicles that we have had a chance to see, I would say this is indicative of this has a max tow trailer tow package, and is probably supplementing this overall system itself. And then as you kind of come through here on your side, there's a supplementary pump here. There is another gate here, another pump here, and then on either side of the frunk axis, there's 2 additional pumps. And obviously lines, to Jordan's point earlier, just when you have to tie all these things into a system, we're running lines, connections, we are managing, every aspect of where this line routing is. If we were able to do something like a manifold with this casting, you could probably have a series of pumps all in line, running to where they need to, similar to the Mach-E. The Mach-E on the front of it had I think 2 pumps, and then we didn't have a GT, but the GTs have a series of pumps that supplement, its thermal management needs. So again, I would hope as we go forward, we'd see a little bit more of that. I would suspect a mid-cycle action Lightning, this would all be in nylon, and maybe a little bit more integration. You can see a little bit on your side. That bracket there is, I don't know,
it's a large
testament
bracket.
to, I don't know, mass. I'm not exactly sure why we have 8 fasteners to secure the actual cooler itself. I think you get away with essentially a series of slots where the cooler would load in, slide down vertically, maybe in these positions here, and then you fasten it with 2 other bolts and get rid of most of those other operations and have a similarly secured cooler or exchangers in that area. So
yeah, I'm with you, Kevin. When I look at this bracket, there's 2 things that Sandy would probably tell you if you've talked to him for any length of time or watched his videos. Munro typically doesn't like brackets, springs, and fasteners. And so there's a lot of fasteners here and there's a bracket, but fortunately no springs. But I would probably guess that that's probably an off-the-shelf component, again, like supplier designed, and so they're kind of constrained in how they can mount it. But the bracket is pretty hefty.
Yeah, at least they are, there's a series of other lines that are being piggybacked off it, so it does serve some other functionality, simply aside from mounting that. I don't know if you want to come around here, Eric, and take a look kind of on this side here. One thing that's pretty cool is, so this line here itself, so the charge port kind of goes up here to the left-hand fender, and this goes up to essentially the hot bottle. And there is which this only has 1 of. The Mach-E had 2, which was not necessarily needed, but depending on how you do the system, you can eliminate it, and that's exactly what Ford did here on the Lightning. So there's a blending valve here where they essentially have crossover between the cooling loops for this vehicle to get to 1 hot bottle, which is pretty interesting. There's still a lot going on there from a routing perspective, but that is a big enabler to not only not package another hot bottle, but all the assembly operations, the weight and coolant that you have to essentially, that comes along with it from a baggage perspective with respect to having another hot bottle itself. But as you can see, from a packaging perspective, I think down the line, there's a lot of room for optimization, but I understand why this is the way it is. There's a lot of constraints with the body and frame with the ICE vehicle.
So yeah, there's a lot going on with thermal management. It's a difficult equation to solve depending on how you can amortize things, how much time you have in the program, so on and so forth. But I suspect that there's some things that they're probably working on to optimize some of their thermal management. So bringing it back to the structural side of things, so the battery pack is mounting here. We brought in the frame. That's that steel weldment down there. So it's a stamped steel welded assembly that the mostly extruded aluminum enclosure, the actual battery enclosure, mounts to. The battery enclosure is isolated to that. So we talked about isolators earlier, right? So the rubber bushings that are bolted to the steel members, it has isolators that are mounted to that. And then that whole assembly, so battery pack and subframe, are decked and bolted to, or hard mounted to this frame. So what you're seeing on the ground here, that's actually supplementing the frame structure. So earlier when I had mentioned we're not seeing as many cross members in the frame itself that we would see in a typical ICE application, they're able to do that because they're replacing some of that cross car structure with what we're seeing in this welded subframe. So I would say looking at this subframe, there's a lot going on here. There's a lot of welding. I think there's some things that they probably could have done to optimize it because there is quite a few components, but nonetheless, it is quite structural. That is not going anywhere. I suspect since it's in production, it did fine with their durability. And so kudos to anyone these days who's getting something into production. It's not something to sneeze at. The overall width of the frame, especially relative to the Rivian when we had looked at that. In the Rivian video, I had mentioned that we took some measurements on some ICE truck cab, like body structures and frames. So we went essentially outboard of sill to outboard of sill, measured the overall width of the cab, the body structure. And then I measured, so two simple measurements, I measured that, and then I measured inboard of frame rail to inboard of frame rail. So I was trying to see how big is the overall truck, within those overall truck widths, how much space do they have within the frame rails to package a battery pack. When I averaged a few ICE applications against the Rivian at the time, the overall width of the Rivian was roughly 5 inches narrower, so about 200 millimeters narrower than this truck, for example. And yet, the inboard side of frame to inboard side of frame was 9 inches wider in the y-axis for those CAD spinners out there. So 225 millimeters. So that's very substantial. One of the primary reasons for that, though, it kind of goes back and forth, right? So this is the pros and the cons versus the Rivian. The pro on this, you get some isolation. So you may have better MVH with regard to everything that's on the frame relative to the body structure. It's easier to deck, significantly less fasteners on this vehicle versus the Rivian. So like I had mentioned, 14 versus 100 plus fasteners on the Rivian. However, these perch mounts, these isolators on the side, are the primary cause as to why these frame rails are narrower in this specific instance. Now, it's not that you can't necessarily have both. I imagine if you spend enough time working on it, you could probably package some of these isolators pocketed in a frame rail or do some different things with regard to the offsets, the Z-axis spacing, what have you. But since this is using an existing ICE platform, these perch mounts, I imagine, are probably sort of sacred points that they're not willing to change just for a BEV adaptation to an ICE platform. And so they're left with that y-axis spacing or a slightly narrower berth for that battery to come up in. Well, you might say, well, why can't these just go further outboard? Let me point it out really quickly as we move over to the body structure. So this is the cab for this truck. As the frame gets decked, those perch mounts need to sit inboard of essentially this flange or this monument right here. So this is where the body side inner and the body side outer, the sill section, come together. So we'd call it the pinch weld, the body side outer inner joint, what have you. Those perch mounts need to sit inboard of there. And so if you went to move it outboard, you're going to be crashing into these immediately. And so saying, well, just move it outboard a little bit, it would actually, in an existing ICE application like what we're seeing here today, that would actually cause a full vehicle architectural change. It's not something that could be done as a running change on this vehicle architecture. So we have not yet torn one down, but I'd be very curious to see how some of the other major OEMs, Ram, Hummer, some of these other vehicles are going to start accommodating that y-axis space, because that's a monumental amount of space to garner from a battery packaging perspective. So that's kind of the main difference here as far as battery packaging and the way it attaches between this and the Rivian. So kudos to Rivian for finding a way to get that extra space, but that's not without the cons, which are the decking, the amount of complexity, the number of fasteners. If I had to produce one vehicle at over 1 million units a year, this would be the one. But if you want to carry more energy, right, more battery, the Rivian obviously has a significantly wider berth for that.
And I would suspect a next generation dedicated BEV, this sweep here on the Rivian is extremely drastic, and it almost kind of takes the place of this Sorb tusk here. And then on this particular vehicle, there's a polymer honeycomb energy absorber. On the Rivian, they actually use that to help join the body, the hinge pillar itself, and the frame. It is a large cast iron structural stop there. But essentially that frame would kick out and come all the way down. I mean, if you were to look at like cars from the 60s and 70s that were body on frame applications, they did that. These big pushes out coming in to, not necessarily to package more content, but it was something in the past that you would see brought forward. But before we kind of go anywhere further, I do want to just call out to this mid-frame module. So on the Rivian, there's a series of stampings. You have spot welded subassemblies, as you guys kind of spoke to, that are brought together, being MIG welded together because there's only one-sided operations, or there's some flow drill screws. There's a whole series of fastening technologies being used to join that frame and that body together. But this mid-frame module here is just one solid piece of pipe tube. It's got a very high frame section height, but it is one solid piece kind of running out. And this execution, whether it was this point, cross car or outward, could be carried over and still relatively simple. I wonder, when you look at the Rivian application, what kept them from maybe adopting a thicker frame strategy and simpler. Because essentially, as you go through, these frame modules, this is just one piece. As you come here, clamshell, inner, outer, and then there's some sleeves over where these monuments are brought together. But I'm not sure if we're gonna cut the Rivian, body apart after everything is done, well into the future, given our current kind of, job stack up, if you will. But the amount of parts and complexity there are just, significantly higher than this. Is it press tonnage? I just would like to know what drives them to kind of avoid a simpler strategy like this. Is it because there are no presses, in that area that have the rate as far as volume and tonnage that they need? Because they're essentially all occupied by the big three up here making BEVs and ICE trucks. But it's interesting to see.
And maybe to shed some light on what Rivian's doing, if you haven't seen that video, in some of these same areas that Kevin's pointing out, they're 3 and 4 layers deep on some of these frame rails. So they've got MIG welding and puddle welding with windows cut in the outer layers, right? So that they can get deeper and weld other panels together. And then they've got flow drilled screws coming in from the side so that they can have single-sided welding operations, because they've got reinforcements running down the inside. Is it constraint of stamping suppliers and ability to stamp thicker panels like that? Is it the fact that they had a very finite amount of packaging for that sill, and they continually found over the iterative process that it was not structural enough, not stiff enough, and so the only place they had to add structure was the inside?
Yeah, I don't know.
It's hard to say.
The ladder tray on this is more akin to the Rivian overall construction of their frame than this frame is in general, just with the, kind of stitching it together.
Yeah. So maybe we can move real quick to the rear to wrap this up. In the rear, they have their Pro Power modules. So they've got one for 110 and one for 220 that's being driven by the high voltage battery. So that's these guys right here, in addition to an onboard charger. And then finally the inverter converter, which lives under the onboard charger and on top of their drive unit. So their motor and their gearbox. Again, just as we had talked about in the front, right? Every one of these modules being a purchase component from a supplier, I can put my hands on all the connections going to these modules. I suspect that in future generations or iterations of this vehicle, or additional generations, right, we're going to see some of these be joined together so that not just the electrical connections, the high voltage, low voltage connections, but the thermal management can all be condensed, and that would clean this up. But nonetheless, they were able to get it all packaged in here. And frankly, there's not many vehicles out there. Actually, I don't think there are any vehicles out there today that can do the same things that this truck can do in terms of utility. You can go charge a Tesla if it's dead on the road. You can plug into your house. You can do a lot of things with this. So I'm sure they went through a lot of trouble to make sure that all of these modules fall below this plane, right? So this plane right here is where the touchdowns for the bed go, right? There's some stampings in the bed that probably allow it to go up and over locally a few spots, right? But roughly, right, they've got some pretty hard constraints in that they don't want to be changing major bed stampings for this application. Ideally, right, you would take a very similar bed, maybe with the exception of the Pro Power panel in the back or that opening, and carry that over from an ICE application.
Yeah, it's one thing that's also kind of interesting here when you look at the different mounts. So these are all kind of floating cage nuts. So on the Rivian, there's a series of fasteners, and I'm not sure if you guys got a chance to call attention to it, that are fixed, not floating. They do use floating, but in this particular area on the Rivian, that are completely obscured and their panels stack up. So they're not being used on the R1T. I wonder if it's an R1S build consideration. I'm curious if they run into like a quality issue, since there's a lot of panels that stack up. Does if you overlap one of these fastener points and you can't engage it, does it go to the truck line, or does it, and if it's good, does it go to the R1S line? It was just interesting to see that those were present and not being used, which makes sense. OEMs give away, commodity clips, brackets, all the time. They give it away for free for the customer. But it was interesting that it was not being used. And not only was it not being used, you couldn't use it if you wanted to because of how off the fastening point was as far as getting access to it, the frame.
Yeah, so if you look down, I remember the point I think you're talking about, there was a panel over the top of the hole that actually covered up half of the bolt hole. So you couldn't even get a bolt down in it if you want to, which the fact that a welded assembly this large is buildable is actually a pretty incredible feat, right? I've seen a lot of applications like this where a lot of these brackets or monuments on the frame, or even some of the piercings, are done post-welding, right? So they'll actually form or attach some of these major monuments or punch holes in this after it's all welded together to ensure a perfect net build, meaning every hole is spatially exactly where it needs to be, or that they've got floating cage nuts like this within an allowable tolerance range to be able to build it and not have that obscuration of that threaded fastener point. So, and you can see, right, every one of the points that needs to adjust in the Z direction to make up for build tolerance. There's what I would call a slit plane here. So this stamped bracket can actually, as it's prior to being welded, it can slide up and down the inner wall of this vertically, and then they weld it wherever it needs to be. So you could put a plane in here, you can have a fixture in here, get these all to the right height, then weld them again, so that if there's any variation in the frame or the major monument that these are being welded to, you're accommodating for that. So
I'm not sure if you can see here with it, but if you want to come around here, Eric. So this more than likely, like this piercing here, all these other piercings are probably done in tool. It's coming off the line, out of the press, just like that. And it's relatively rounded. But when you look at some of these other, this has it too, it's a little cleaner on that side. It might be indicative when you look at the actual surface finish of it, that it's essentially a net piercing or cutting operation after the fact and not done in tool. I mean, we would advocate, if possible, to do it in tool. Why not? We've had suppliers that have built cradles for cars that are, extremely high performance, deliver some of the best, lap times in the industry, and they do pierce in tool. So it just, obviously things stack up here. and it gets difficult from a build perspective. And they build at volume, and which is why there's so much compliance throughout the vehicle. They have these little decking cones, which I really dig, to help bring the bed down and keep it aligned to the cab. It's interesting. It's simpler overall, which is why I think they can essentially come in at a relatively low, MSRP price and probably not give too much away. Even these, like the suspension itself, progressive rate springs, you can see these are riding on it, where the Rivian has a significantly more complex, dampening system itself. This is just steel, just a steel coilover dampener. And it rides pretty nice, a little soft. I think my truck's a little stiffer, but there's definitely I think overall, a significantly different approach and complexity difference between this and the Rivian. I frankly can't wait to see what the EV Hummer or the EV Silverado looks like, because it'd be a all new BEV truck that is not necessarily tied to like a legacy ICE vehicle, and what it looks like. Because I think some of those other issues that we've we're beating up the Rivian pretty hard here, but that we saw on it, I don't think you would see on a GM truck, because a lot of this stuff has been kind of beaten out through years of production and production woes, where they're kind of going through it collectively as a company for the first time. So,
well, we're excited to tear it down. We've been waiting a while for it to show up. So we're going to dive deeper via some future videos here and thermal management. Certainly the drive modules, probably talk about suspension a little bit. So stay tuned. Thanks for joining us for another episode, and we'll see you next time.